the explicit rule. The explicit rule has been what we've been writing out in terms of generic. What's the generic rule for geometric? The generic rule for geometric, we would say the explicit for sequences would be a sub n is the first term times the rate to the n minus 1. That's the explicit. We said that was explicit, or we called it, a lot of times I said it was the generic formula. So those are one and the same. Synonymous. Look at that. Now, what we're going to do today is talk about recursive. Recursive is a way of writing out a formula that relates to the number, to the terms in the sequence to the term that was before it, the preceding term. It's kind of a weird way of doing something that is extremely simplistic. So let me ask you this. If my term that I'm looking at is the third term, what would be the term before it? The second. So that means I'm going to be writing these rules in terms of the term before. So instead of being n, it would be n minus 1. Now, with recursive, there's really only one rule. You have to know where you start. If you don't know what the first term is in a sequence, you can't write the rule for recursive. So all throughout these different setups, whether they were arithmetic or geometric, you guys have always been able to write out the first term by using the system of equations and going through that if you had to, or some direct substitutions. It means the same thing today. And you're going to see how quickly these things are all blended together. So let me show you an example. Let's look at this arithmetic sequence that I have the first term and I have my difference. Remember, arithmetic, you always have differences. Geometric, you have rates. Okay? So I'm going to do two things. I'm going to write out the explicit rule, remember, generic, whatever the normal thing is. And then I'm going to write out the recursive. So the explicit rule for this one tells me that I have to use the generic formula. And I've been asking you guys all along to start your problems by just writing it out. And the reason I was doing that is it kind of helps you ingrain it in your mind, helps you memorize it, helps you remember it. Okay? So if that's the explicit rule, the generic rule, I know what the first term is and I know what the difference is, so what do?
Substitute.
You substitute in. So the nth term becomes 4 plus n minus 1 times my difference of 3. Everybody agree on that? Now what do? Distribute and simplify. Do you agree? You get your nth rule, it would be 3n plus 1. That's your explicit rule. The recursive rule is a little bit different. The recursive rule has two parts. The first part starts out very similar. It's an nth rule for the recursive. But you also have to tell me what the first term is. Well, in this case, what was your first term? 4. That's very easy. All we do is write it down. And now we have to relate each term in that sequence to the term prior to it. So instead of talking about a sub n, I have to talk about a sub n minus 1. Very good. The term before. And what do you do to each term before it to get to the next term? Think about our sequence here. Our first term was 4, the next one was 7, the next one was 10, the next one will be 13, and so on, right? What are you doing each time? You're adding 3 to the previous term, right? There's your rule. Writing rules for recursive seems like it would be a whole lot more difficult than it needs to be. Because each one of them is the same. You always will start out, for if it's arithmetic, with that, and then you just tack on what your
Is that the
difference
same
is.
for all the functions, like addition, subtraction?
Yes, for addition. For arithmetic, it's the same thing. The d value, whether it's positive or negative, which is plus 3. If it was minus 3, great, minus 3. The first term is going to change each time depending upon what the sequence is. Here, the first term is 4. That's all it means. Okay? Like I said, it's not that complicated when you start looking at it in terms of the actual sequence. Well, if the first term is 4, how does 7 relate to 4? Well, the second term is taking the first term and adding 3. The third term is taking the second term and adding 3. The fourth term is taking the third term and adding 3, and so on and so forth. It's like the whole idea of Pete and repeat were to vote, Pete fell out, who was left? Pete and repeat were to vote, Pete fell out, who was left? Pete and repeat were to vote, Pete fell out, who was left?
Guys, come on.
It's kind of, it's along that line. It's the recursive rule. The recursive rule is looking at what happened before. Okay? That's what it is.
That's what I was gonna say.
Nothing.
How do you know?
Because it told you. Yeah. Was that too much there with the repeat? Okay.
Oh my God.
But it's not always given to you as first term is this, difference is that. You might have to solve for that. Okay? Which is something you have done. We have to be able to look at it, given 2 bits of information, to be able to take that information to figure out what was the first term and what was your difference. When we're dealing with arithmetic, so this is another arithmetic, I don't know if you can read that. When we're dealing with an arithmetic and we've got 2 terms, how many times did we write up the generic formula, the explicit formula? Twice. And then we did some systems of equations, didn't we? All right, let's go for it. Let's walk through it. I'm going to write out the formula twice. One here and one there. It is kind of helpful, isn't it? I know that the 13th term is 1181. That relates to the first term. What's the n? Oop, this is 13 minus 1 times my difference. So 1181, first term, plus 12. Everybody okay with that? Substitution, simplify, that's all I can do. Okay. I do the exact same thing with the 38th term, just like we did a couple of sections ago. Wait, whoa.
Can't come here when you're
Sorry. Okay? So I do the exact same thing with the second group of term. I know that the nth value here is 3681. That's the first term plus 38 minus 1. So 3681. I have those 2 equations. Are we okay with the idea here that I'm just going to take the one in red and subtract it from the one in blue? When I subtract that all out, you might be pleasantly surprised. What's your D? What was it?
Maybe possibly.
Maybe possibly 100, and maybe possibly I'm agreeing with you.
I'm not very good at dating.
So our difference in this case is 100. Everybody's okay with that, right? Okay. Now, to figure out my first term, remember, all we did was just substitute in. I'm going to take this, substitute there. So what's 12 times 100? 1200. So I have 1181 plus equals something plus 1200. Move it over, you should get negative 19. So now I know what my first term is, and I know my difference. I can write my explicit formula. I can substitute into this now. Okay? So a sub n, first term, plus n minus 1 times our difference of 100. Distribute, combine. Uh, 100 n minus 119. That would be our explicit formula. Is everybody okay with that? Okay. Now, to write it in terms of the recursive, all I need to know is my first term and my difference. So this is my explicit. In recursive, I feel like I should write that in cursive. Maybe not, yeah. The recursive, it's not really that much better, sorry. You start with a sub n, will be the term prior to it. And what do you do to each term prior? Oh, what's the difference? What's the difference? Plus 100. Our difference is here. Okay? And what was your first term? And you have to write a sub 1 is negative 19. And that's how you write out recursive for arithmetic. Yeah.
What is the point of that?
It's another way to write out formulas. A lot of times, to be honest with you, I really don't know why there's a huge reason why we need to know this. But the state of Illinois decided that this year you need to know this. Yeah. I think it was just in. Yes, sir.
How can a sub 1 equal a sub 1
What happens there is that the term you're looking for is the term before it plus 100. So if you're looking for the second term, you're looking at the first term and adding 100. Does that make sense? That's what that means. Yeah, it's kind of a weird way of thinking about it. But that's just another way of doing it. Yeah, Mike. What's that?
about
Oh, that's right. It said find a sub 8. I think that was just an instruction. I'm not really worried about it for right now. If you had to find the 18th term, whatever, you just substitute into this and you're done. That's easy. Okay. I made this out of a quick little thing that I found. I just put it in the notes just to make it to show you how the recursive works really quick. All right. Now let me show you how this works with geometric. You should be pleasantly surprised at how easy it is with this as well. So when we're talking about in terms of geometric, when you're looking to write the rule, the explicit rule for geometric, we need to identify the rate in first term. Well, just so happens that they decided to be very nice to you today and give you the rate and the first term. Yeah. Oh, it's so nice. So from this point, all I need to have to do is thank you. There's my explicit rule. Okay? When I go to write recursive, I have to relate that to terms prior to it. I have no idea what you two are. I don't like the two of you sitting next to each other like that. The recursive rule, all we do is we write out your a sub n relates to the n minus 1. But what do you have to do to each previous term? What are you multiplying it by? The rate. So what's the rate? 0.1. Now, a lot of times what they do is that they'll put the rate before the a sub n minus 1 just because it looks cleaner. So you'll see it written like this.
Subs
They write it like that sometimes just to make it look cleaner.
Big.
Hey, are you going to play golf the next Tuesday? Alright, I'll call this again.
Oh, you guys are playing down there?
Yeah.
Oh, I gotta go all the way to Sean. No, because I gotta go back and meet my dad and my brother. But well, I can maybe drive down.
Oh, look at it. I know sometimes I go to
Oh, but I
I'll
don't.
go by myself.
Oh, I thought you were gonna play out here.
No.
Hey, were we gonna tell you there was a math team meeting before the announcements yesterday?
Did I not tell you?
I
I'm just
might.
gonna tell everybody what I know so far.
I don't know if I can or can't make it because text might have Drew.
Oh, yeah, no, that's fine, that's fine. Yeah, I'm just telling everybody, it's just, I'll be done in like 5 minutes. I just want to say, hey, this is what's going on, here's the idea, here's your schedule, what we know.
Okay, you wanna come up for next Tuesday, you wanna come with that Tuesday? Wednesday? Yep,
We'll come with that, and then I'll have, when I don't meet, I'll come back up here and have it.
It looks like you can't even say the word bad. I had to read the caption to know what it said.
Okay.
Yeah.
How was your wedding?
Really good.
You got
Ask
married, did you
Mr.
guys?
Murphy, he knows.
It was a lot of fun.
You were like, yeah, I asked you. How was the rhino theme?
Did you
It worked out really well. We got really good pictures with the rhino.
did you guys like process down on rhinos or?
We took some pictures by the rhinos, and it was really
The deal with geometric is they usually put the rate in front. It just looks cleaner. It's not, it's like saying 2x instead of x times 2. They put the coefficient first, that's all. And then, what did I forget to write in here? First term. So my first term in this case was what? Is it 3? That's all it is. So when you're writing out recursive rule, all you have to remember is you write out the explicit, in other words, your generic formulas. From that, you blend it down and you get into the recursive, which means how does it relate to the term preceding. So it's how it's generated, okay? It's not that painful. We will test out of this stuff on Friday. What I have for us tonight, as far as the homework is concerned, is I did not like any of the book work. I wanted you guys to be able to do stuff where you had to develop the formulas themselves. I wanted you to take a couple extra steps to get to it. So I made a little bit of a worksheet. It's got a lot of review stuff from the whole chapter. We're not doing all of it yet. We'll get into that over the next day or so. Yes, ma'am.
I was wondering if before every test you give us like it's like
It depends on the material. It depends if I can find something that's good. Sometimes I find good stuff. Sometimes I don't. It really, it's all.
like I'll say you test on Friday. Guess what?
Wait, are we gonna get anything to help us on our test this Friday? Like a note card or anything? No.
Okay. Quizzes in here?
Yeah. What's that? No point.
So we're never done.
We do. Quite often. Not this chapter. What I would like you guys to do on this worksheet, like I said, I came up with a bunch of different things here. I'd like you for tonight just to do 31 through the end. It's 31 through 40. It's 10 problems. If you read the instructions, this talks about if it's geometric, it tells you if it's arithmetic, and then it wants you to write the explicit, and then it wants you to write the recursive. Start on 31. I want you to do 31 through 40. If you have time or you're really bored or if you've got a bus ride somewhere and you want to start working on the other stuff, it's all there. Also, the answers are on the back. Okay? So you should be able to check yourself, make sure you got it right. Make sure you read it carefully. There's a couple parts to these problems. It shouldn't be that bad. This is a good review for a lot of the other things. We will go back tomorrow and talk a little bit about the sum of the series. We didn't do a lot of that today. I want to go back and revisit how you solve for n in both those instances. whether it's using logarithms again, or it's using the systems of equations with your calculator. Okay? All right, you guys got a little bit of time, a couple
Will
minutes.
30 be assigned eventually?
Eventually, yeah.